Everyone, and welcome to our webinar. So today is my great pleasure to have with us Yadu and Julien.
Hello, everyone.
Welcome Yadu, welcome Julien.
Hello.
And we'll be talking about the Zenoh RMW, right? Okay, so I suggest that we get rolling, guys. Maybe right before starting, showing slides and perhaps interesting demonstrations, I would say quick round of intros. I mean, everyone knows me, so ZettaScale CEO and CTO, Julien.
Senior solution architect at ZettaScale, working on the plugins for Zenoh and especially the bridge for ROS2, but also contributing to RMW Zenoh with the help of Intrinsic.
Yadu.
Thanks, Angelo. Hello, everyone. My name is Yadu Nand. I go by Yadu for short. I'm a senior software engineer at Intrinsic, and I've been helping out with the development of RMW Zeno.
Okay, great. So I guess we'll get started perhaps giving some context. So Yadu, do you want to share some slides?
Absolutely. Just give me a moment.
Yeah, and we should be seeing your screen. I'll give you. So we can see your slide, Yadu.
Okay, on that note, I'm going to jump in. So I have a couple slides here prepared just to kind of go over what we've been developing here with RMW Zeno, set the stage for the demos we'll do, and also for the later half of this presentation where we'll talk about comparisons between RMW Zeno as well as the Zeno DDS bridge. So with that, let's jump right in. So just for completeness, here we're talking about a middleware for ROS2. And ROS2 is the most popular publicly used robotics SDK. It's fully open source, and it allows users to write distributed applications for robotics. So in a typical application, you would have robots with a variety of nodes that each perform a specialized task related to motion planning, control, or retrieving information from sensors. And oftentimes, these different nodes would need to exchange information with one another. And this is where we rely on a middleware layer to pass information between these nodes. And with ROS2, really, we have a very modular architecture. Not only is the client library that you use to write these nodes modular and flexible, so you could use Python, C++, Rust, Java. There's a whole bunch of different SDKs and different languages that we support. So not only is this level modular, but so is the middleware layer. And this is what we call RMW, or the ROS middleware layer. So deep down inside, once you write your nodes, you'll be establishing entities like publishers, subscriptions, services, clients, etc. And the underlying transport mechanism for these entities is defined by the middleware layer. So far with ROS2, since its inception, a lot of the middlewares have been DDS-based, at least the tier 1 middlewares that we support out of the box. And there's a bit of historical reasons for this, right? So DDS was chosen for really good reasons. It's one of those protocols that implements peer-to-peer communication, so you don't require a broker or a man in the middle to forward messages from one entity to another. And if you recall from the days of ROS1, this was one of the big challenges, right? So there was a single node of failure for ROS1 systems. So as long as the ROS master went down, all of your nodes would stop communicating, and in order to have them recommunicate, you would need to restart that master and then restart all your nodes once again. So with DDS, we sort of alleviated that problem. We have peer-to-peer communications between all entities within the system. The protocol is also standardized by the OMG group. There are several vendors and open source implementations of DDS, which we could piggyback on. Again, so ROS2 is open source under Apache 2.0 license, and we want to use other middlewares that are similarly open sourced. But more importantly, DDS is battle tested, right? So we see it deployed in several critical systems, from defense to aerospace, finance, etc. But most often we see these deployments on wired systems where the endpoints of entities are known beforehand. But more recently, we've been on the hunt for an alternative middleware. This is primarily motivated by two reasons. One is, since the start, we always wanted DDS, or we always wanted the middleware layer in ROS2 to be middleware agnostic. So given the modular architecture, we wanted to be able to support many, many different kinds of middlewares. But unfortunately, it's mostly been DDS-based implementation so far. And what we're seeing starting to happen is we're seeing a lot of specifications of the middleware, like DDS specifications, being leaked into the rest of our APIs in ROS2, from the RMW layer to the RCL CPP layer and RCL layer as well. So one of the motivations is, find another middleware we can support so that we can be more strict on making the client libraries a lot more middleware agnostic. Another issue is that we're seeing issues with out-of-the-box experience for new users in robotics or new users in ROS2. So DDS works for most applications, but it requires an additional amount of tuning or knowledge about how networking and systems work. And oftentimes, some of these failures are silent, and they result from certain underlying mechanisms within DDS. So DDS relies on UDP multicast to discover other participants on the network. So oftentimes when you start up your system, your network interfaces are flooded with discovery packets, and you're trying to discover one another. And oftentimes you might either not be able to discover everyone, or perhaps your transport is affected by this discovery. So it often led to users complaining about discovery issues, messages not being transmitted over Wi-Fi, other networking issues, and just how complex it could be to set up DDS within containerized environments, right? So modern computers are much more better suited for TCP transports, but UDP requires certain tweaking at the kernel level. So oftentimes our solutions have been to increase the size of UDP buffers on your Linux systems to solve some of these problems. So sometime last year, the Open Robotics team from OSRF conducted a study on alternative middlewares that we could consider. So this was a very exhaustive study where we considered more than 10 different middlewares, and we had various criteria to rank each of them against, sort of to benchmark them against what users expect, as well as what we've come to expect after using DDS for over 8 years now. So from our analysis, we concluded that Zenoh met most of our requirements. And for the requirements that it did not meet at the time, there's either a plan to have this addressed in the coming year, or it can be developed using existing mechanisms. So I have a link here to the full report that we published on Discourse. So this includes the questionnaire we sent to users, the analysis from the results, as well as some of our insights. So we have all of this data presented in a nice table. So I encourage everyone to check this out. But the key takeaway here was that we're going to develop the next middleware based on Zenoh. So on that note, I'd love to highlight a few key features of RMW Zenoh. So first and foremost, you can find the code base for RMW Zenoh at this GitHub link right here. So it's github.com in the ROS2 org, and the repository is called RMW Zenoh. So how do we use Zenoh to alleviate some of the discovery-related problems with DDS? So firstly, Zenoh allows us to configure the topology of our networks as we wish. So in our case, if we look at a single robot use case, we now have a Zenoh router. So this is a process that's running in the background, and it's acting as a broker for discovery information alone. We still rely on individual nodes exchanging information in a peer-to-peer manner. But what happens is when a node starts up, it looks to connect to a router, and the router is able to forward discovery information from other nodes in the system to this node via a mechanism called gossip in the Zenoh protocol. So this way, every node is communicating its presence only to a single entity. You don't have that quadratic scaling of discovery traffic in your system. I would also like to highlight that all of the discovery information is shared over TCP, and so is the data transport as well. And the cool thing about this topology is if we wish to connect two different Zenoh systems or ROS2 systems on different subnets, on different WANs, etc., all we have to do is just bridge the two routers. And this can be done with simple configs, as we'll talk about later. And again, once you bridge these two systems, it's not each participant in each system discovering every other participant. It's rather the information is forwarded from one router to the other. So talking a little bit more about the router. So we mentioned that it's a broker for discovery within the robot or within your system. But it does more than that, right? So it's a single point connectivity with the outside, however you define this outside. and it allows you to very easily configure the behavior of messages that need to be exchanged, of discovery information. It basically allows for better connectivity management. It also allows you to configure security and access control. You can specify who can listen to what topics at what point in time. And it also allows you to shape the traffic within your system. So you can restrict how much information goes out of your system. You can limit what topics are can be seen from outside the system, or whether you want to enforce some kind of compression or TLS, etc. So there's many ways to configure RMW Zeno. We have configurations that you can add at 2 different levels. One is at each node, as well as the router. So with the router, we already talked about some ways we can configure it. I'll just quickly highlight that we can configure ways that the router connects to the external world. We can specify TLS configurations, access controls, and also downsampling, among others, including compression. On the session side, this is basically the Zeno instance that runs within each node, a Zeno session that is created per ROS2 context, I should say. So by default, it's configured to connect to a router. And by default, it's only exchanging discovery information with the router. All other information exchange, including your regular ROS2 messages, all of this happens over peer-to-peer TCP transport. So there's a lot of information on how these different configurations affect your system, as well as how you can configure them. So for now, we provide a set of default configs that we think will work for most users out of the box. Again, one of the big issues was this out-of-the-box experience with DDS. So we've tried to tweak some of these config files, and we've adopted this topology, which we think will work for many users right out of the box. I'll just quickly highlight on some other capabilities in RMW Zeno. So currently, when you build RMW Zeno, by default, it's only going to build certain features that we require, so the bare bones from Zeno. But if you're more familiar with the Zeno protocol and you want to use some of their more advanced features like QIUC, WebSockets, VSOC, serial, etc., it's very easy for you to just update the CMake lists file in RMW Zeno to be able to build Zeno with these features. I forgot to mention at the start, but RMW Zeno is using the C bindings for Zeno. So Zeno itself is written in Rust, and they provide bindings in many languages, including C. And we chose to work with the C bindings. And that was my last slide.
Yeah,
I've been talking for a lot of time, so.
Yeah. So, and by the way, that's an important slide, because if we go back, for instance, conceptually to the slide in which we were showing the router, right? If I'm connecting over the internet, maybe I want to use Quick on the router, right? And that's a possibility. I want to enable compression, and those are all features that could be, enabled by configuration. And I mean, without anticipating too much, but what I really look forward, right, coming then in Zenoh RMW, is the ability to leverage shared memory and zero copy. And another point that is quite important is that all of a sudden we could have zero copy within the nodes, and the router would be the one that would know when actually send the actual data across the network. So that would also be quite nice. So I think the architecture that eventually was defined for the Zenoh RMW, I think it's super flexible. Yeah, there are quite a few things that could be exploited.
Yeah. And I think also another important point is that the router is indeed required at the startup of the ROS nodes to have all the discovery and the interconnectivity between the nodes. But once the nodes are here and interconnected in peer-to-peer mode, the Zeno router is no longer a single pot of failure. It can crash, you can restart it, you can change the configuration and restart it. Still, the nodes are communicating peer-to-peer, and your robot is still functional, operational, right? Yeah. Which is a huge difference with regard to ROS1, where the ROS master was really required for the communication.
Yeah. Okay. So, by the way, guys, we've been talking about this. I mean, we know that there was lots of curiosity. Should we show it? Right, as people say, show me, right? So should we jump to some actual running code?
Yeah, that's a good segue. So I hope you can see my screen still.
It's all black at the present time. Yeah, now we can see a terminal. Hold on, now it's black again.
No, that's a terminal. Terminal is black.
Oh, sorry. Yeah, no, that's fine. That's actually Terminator on top of that. You're using Terminator as a terminal. Yeah, no, but that's some icons that were showing the the bar, so I could see only. Yeah. So that's good. We can see. We can see
let
your.
me retry that. Sorry.
So you need to display.
Is this showing up better?
Yeah, that's showing up.
Okay, so you should see 3 terminals here, and I'll just walk us through some quick demos. So again, this is RMW Zeno built from source. I'm running it on Iron, but we support Jazzy and Rolling. Eventually, we will support also binaries for RMW Zeno, but for now, we have to build it from source. So I have a workspace here with RMW sourced, as well as the environment variables exported to set the RMW to RMW Zeno. So let me start with a quick example of running the usual Talker demo. So if we do ROS2 run, demo nodes cpp Talker, you'll see that the application starts, the node starts, but you start seeing messages printed in your terminal, and they say, unable to connect to a Zeno router. Have you started your router with ROS2 run, RMW Zeno CPP, RMW Zeno D? So again, this is a check we have in place right now, given the out-of-the-box experience we want users to have. So it forces users to start the router. But there are many, many ways you can configure this system. So you can also skip this check. We have environment variables you can use to avoid checking for this router. You could also completely change the configuration of RMW Zeno so that you don't do this kind of brokered discovery, but you want to do full multicast just as DDS. All of this is possible. It's super flexible. But here we're focusing on this seamless out-of-the-box experience for users that we think will work for most applications. So the default behavior is to prompt users to start the router. So I'm going to go ahead and start the router here in another terminal. So as soon as the router is started, the listener, the Talker application is going to connect to it, and then it's going to initialize and execute its behavior. Similarly, I can also start the listener here. And since the router is already running, it should readily start receiving packets. So here's a quick Talker listener demo that we're all familiar with in the ROS2 space. But as Julian just highlighted, we could go ahead and kill the router process. So I've killed the router right now, but you still see transport succeeding. So this goes back to the topology we've adopted, where transport is still peer-to-peer. It's not brokered. So there's no single point of failure within the system. The only challenge now is if you have another node that's subscribing to it, it perhaps wouldn't be able to discover the Talker node and wouldn't be able to get the messages. The solution is really simple. All we have to do is run this router again. I'll just pause there in case Julian or Angelo want to comment on anything.
No, I think that was crystal clear. Yeah. But that's too easy. That's too easy, guys. Doesn't impress me. So impress me, please.
Absolutely, Angelo. So let's see. We've tested RMW Zeno with a variety of applications that spin up hundreds of topics, services, actions, etc. So I think one very popular application that we'd like to show is nav2 running with RMW Zeno. So here I'm going to run nav2 locally. I should mention that this is a cloud instance. I think the instance is based in Singapore or in Asia somewhere. And this is running within the Linux system on the cloud. So here is the nav2 application that we're all very familiar with. So it's just a simple TurtleBot 3. I will go ahead and localize the robot. And right off the bat, you can tell that the transport's working really well. You can look at all the transient local messages that come from the different cost maps and the background maps. And functionality should be identical as to what you're used to with the regular nav2 stack. So here's just an example of me sending a goal. So this is a ROS2 action that's implemented as a pair of service as well as a feedback topic. And here we're relying on Zeno query mechanisms to be able to send services between nodes.
Nice.
Yeah, that's nice. And also
already smooth.
Yeah, it's smooth, and the startup time was quite short too. Yeah, so that's quite nice.
Exactly. So even though we need to run a router, it's not like you have to wait for a really long time to be able to discover all the traffic.
Yeah. And again, the router also takes a chance of making, I think we've explained in the past how Zeno Discovery works is very different from DDS Discovery, right? Because we can do generalization, And as we'll explain the second part of the webinar, the way in which action and services map also helps further reducing the discovery, but we'll get there.
Yep.
So should we run something in Paris?
Yes, what if I can join the demo, for instance?
Yeah.
So let me share my screen.
Okay, so hold on. Let's see what Julian has to show. So let's keep running. So the Yadu screen, the attendee
Okay,
can still see Yadu
yeah,
screen in the
still
bottom
running.
corner. Yeah.
So actually, what I'm do
So
now is in those three terminal. In the first one, I'm connected to a cloud instance, a VM hosted in Linode. I think it's somewhere in Europe. And here I'm starting just at Zenoh router. And what we can see already in the logs is that Yadu's configuration was configured to connect this router. So we can see already in the log that there are some incoming connectivity. And now here, I'm starting another Zenoh router, my own Zenoh router on my laptop, which is also configured to connect to this router in the cloud. And here, for instance, I will just increase the font in this one. Oops, I cannot increase the font, but I hope you will see. And I will do ROS2 topic list, for instance. Let's see what I get.
And there you get the topic list.
And here I get the full topic list from your robot, Yadu.
Yeah.
Which is being simulated in Singapore.
Yes.
It is. It's running on a cloud instance in Singapore, and you're sitting in Paris, and you're able to get those topics.
Yeah.
Exactly.
Do you want to show the graph?
Yes, we can start also RQT, for instance. And we'll get the complete graph of the system here from Paris. My computer is quite slow because it's sharing at the same time.
There we go.
Yes.
Whoa. So it's no simple graph. So yeah.
Quite a graph.
Yeah, now it's quite the complex application.
Yeah, but that's good. If it's too simple, it isn't. Yeah. Okay, so you want probably to show that.
And maybe I can also try to control your robot from here.
Yeah.
So starting
RVs
now.
Maybe we could have Yadu driving it, so we can see it moving, and then you give a target, and then we switch the screen.
Yeah.
Yep. Let me set it a goal.
My RVs started just here.
Yeah,
I need
you can see RVs
to load the config.
There we go.
Showing up.
Okay, there we go.
Yeah.
Okay, so do you want to move the robot, and then we'll send a goal?
Go ahead, send a goal.
Sure, I'm going to move the robot, and we can have Julian.
Oh, yes. Yeah, you can see. Yes.
Yeah.
Hold on. Let me change the visualization because we have our faces on the robot moving. Yeah. Now it's easier for attendees to see the robot moving. And then, Julian, maybe you can give a goal.
Yeah, you can preempt it right now by giving it a good new goal.
And then I will show your screen. We will see full screen. We will see the robot moving. Yeah. Yeah, there it is. It's moving.
Awesome.
Okay. And we can see it from your, cool.
Here we are, fully distributed ROS2 demo across the globe.
Indeed. And that's something, I mean, I mean, those that have been working on ROS probably appreciate that this wasn't at all easy, if at all possible, to achieve with other RMW in terms of this level of distribution, which is nice. And I think especially with robots being teleoperated and more robots being mobile. By the way, I read somewhere a report that was quoting 80% of mobile robots using or being ROS-based, which is quite impressive.
Yeah.
So I think this RMW will make a few people probably happier or make their life simpler. Yeah.
Even for remote support, remote supporting a robot, for instance. This might be very useful. Right?
Okay, so by the way, we already have a question. We have the answer later on, but might be worth answering immediately. So the question is, does this approach guarantees that you always see all the topics coming from a process? I think they mean a node. So do they see all the nodes in your ROS system?
Yeah, I could take that one to begin with.
Yeah.
So we think the current topology of Zeno makes it a lot better to get all the topics right at the start. For reasons I explained earlier, we're not flooding the network interfaces with discovery packets at the start, doing this quadratic polynomial discovery behavior. So we think the performance should be a lot better. And this is what we're hoping the community can give us feedback on. So the repository is open source. Please give it a shot in applications that you've run before, maybe had some kind of challenges. We'd love to hear how things are improved or maybe still broken, or just feedback would be great. Because it's one thing for us to say it's going to be better, but we'd like to hear it from everyone else.
Of course. And by the way, there is a follow-up question that says, with DDS, sometimes you only get half of them and you need to issue ROS topic list a bunch of times. Any comment?
So what's happening there is there's when you run any sort of CLI command like ROS2 topic list or node list, you're actually starting a ROS2 daemon in the background. So it's just a Python process that's running in the background. And what we're relying on is perhaps that Python nodes discovery to finish in the background. So the more times you run it, you're just giving it more time to get all this discovery traffic, and then you'll be able to see the results. Okay. Whereas what we do in RMW Zeno is as soon as you connect, as soon as you start a node, as soon as you run ROS2 topic list, the same daemon, it's going to connect to the Zeno router. It's going to get all the traffic that's already on the Zeno router, all the discovery information from the Zeno router, and have that information available for you right at the start.
Yeah. Okay, we are being overwhelmed with questions. I suggest that we keep going with slides, because some of those slides will be answered by the slides, and we'll get back. Okay, so by the way, guys, thank you. Very nice demo. But I know that you would have not disappointed our attendees. So that was a very great demo. Chapeau. Okay. So Julian, I guess it's for you to share your screen.
Well, if you can share the slide, because I can try to
whatever you prefer.
Okay, I'll try to share the slide from here, and we'll switch back to your host if I have an issue with sharing, because
because this
Linux is really slow.
Yes. Okay, so you are on the stream.
Yeah.
Okay.
So a lot of you are already familiar with the bridge ROS2 DDS that we already built a few months ago, and even with the former bridge for DDS that was also built several years ago now.
Yeah.
And now that we get RMW Zeno, what are the real difference between each, and when can we use the bridge, or when shall we use RMW Zeno? So first, just a comparison between topologies, right? On the left, you have the topology of just a simple system with two distinct system, ROS2 system using DDS and interconnected by Zeno bridges. So in each system, you have DDS running over UDP, over both UDP multicast and unicast. And in the middle, you have the bridge, which are interconnected via TCP connectivity. So the bridge are already doing a translation of protocol between DDS and Zeno protocol.
And again, TCP by default, but you could select quick, you could use TLS, you could have MTLS.
And for Zeno, yes. For Zeno, you have already a big choice of transports being available with Zeno. With RMW Zeno, it's still Zeno all over the place. So all of the communication internal to each system, but also outside of the system between two Zeno routers, for instance, are using Zeno. And then can be configured, as you said, with different connectivity. You could have shared memory or even UDP inside your robot, but still having TCP or TLS, for instance, between your two Zeno routers. That's the first overlook of differences between the two systems. Now, with regard to the configuration, in both cases, the bridges and the Zeno router, you're using a Zeno configuration, which is a JSON file. By the way, it can also be a YAML file, because Zeno also accepts YAML syntax for the configuration file. But the syntax for both bridge and Zeno is similar. For the bridge, you have a specific section which is regarding to the ROS 2 DDS plugin here at the very end of the configuration, which is everything related to the ROS 2 DDS plugin. But for connectivity part, for Zeno connectivity part, it's always the same. You have the connect part, which is where your bridge or where your Zeno router shall establish a connection to. And you have the listen part, which is what are the transports on which the Zeno bridge or the Zeno router are listening
peer,
on,
yeah.
or peers. Yes. So here, by default, in both cases, for the bridge and for RMW Zeno, they are by default listening on TCP on any interface on port 7447. And if you want to establish a connection with a remote system, a remote robot, for instance, you just add an endpoint TCP/IP address or domain name of your host on port 7447. And that's it. So actually, I think I missed a slide, which was, yes, this one, which is exactly the configuration of the demo we had just a few minutes ago. So hold on, let me go back to full screen. So that's exactly the configuration we had, Yadu on his side and me on my side. So we had this Zeno router running on this host demo in Linode Cloud in demo.zeno.io. And we just changed the router configuration, adding a connect endpoint to tcp/demo.zeno.io port 7447. Yadu on his side and me on my side. And as it's outgoing TCP connection, there is no need to configure any port forwarding with a NAT or so on. The router is routing back the traffic from the same incoming TCP connection, and we are in business.
Yeah,
quite simple. So now, what if I would like to connect a fleet of robots? So I have a fleet manager, which is already a ROS system in itself, and I have a set of 3 robots, which each robot having its own ROS system. 2 possibilities. Either you configure the fleet manager to connect all your robots, so you just change your router configuration in fleet manager to list all the robots it needs to connect to. And by the way, if one robot is not reachable because it's still booting, right, the Zeno router will keep trying periodically to reconnect to the robot. If the communication goes down, again, it will see it's disconnected and it will periodically retry to reconnect. So the connection will eventually be reestablished with all the robots. The other possibility is to configure the other way of connecting. You have each robot configured to connect the fleet manager. So in each robot, you just copy paste the same configuration, the connect endpoint, to the fleet manager host.
Yeah. And by the way, in the second case, for instance, that name could be a DNS. That DNS could be resolved locally to a different IP address.
Absolutely.
So you could have even multiple routers that they connect to, that they are interconnected, and everything becomes quite nice.
Yes. Yeah. And even if you need also to have all the robots to establish direct peer-to-peer connection, you can also add here the direct IP address or the DNS name of the remote robot. But you could also activate the gossip algorithm for the routers and configure them to auto-connect to other routers.
Yeah.
And all of a sudden, Zeno will establish automatic full connectivity between all the routers in your system. That's also an option which is deactivated by default because we don't want all the routers to interconnect by default. It's preferable to control exactly the connectivity we want, but still you can activate it to have an automatic connectivity. So another example of configuration is TLS. So Zeno supports TLS. Server authentication, but also mutual authentication. So here we have a full description of the connection. Of course, you need to generate some certificates, a root certificate and a server certificate with server private key. If you want to enable mutual authentication, you configure the client auth to true, And then you also need to provide client certificate, client private key. And you can also disable server name verification in case your certificates are bound are for IP addresses, for instance, which are not verifiable by DNS. Then you need to deactivate server name verification. And by the way, this same configuration was working for the bridges and for RMW Zeno. So here, no surprise, it's always the same. Downsampling. So downsampling was a really interesting feature we had in the bridge, which allow really to tune exactly the bandwidth that we want the robot to use over wireless network, for instance, because all wireless network cannot afford to have a publication of a huge LiDAR, for instance, or point cloud at 10 hertz or more over
100 hertz,
100 hertz sometimes over the wireless. So it was really convenient for a lot of users to be able to tune the downsampling of some topics published by the robot over Zeno. So it was a configuration in the plugin ROS2 DDS named pub max frequencies, where we specified a regular expression to the topic name and frequency in hertz. So we just recently added this same feature in Zeno router in Zeno version 0.11. And it's now available also for RMW Zeno. So you can just configure your Zeno router with a downsampling section. Here, it's a little bit more complex because for DDS bridge, it was quite simple. You have DDS on one side, Zeno on the other side. So it's always on Zeno side that you are downsampling. Here, the router has Zeno everywhere, right? Zeno internal to the robot and Zeno over Wi-Fi interface.
Potentially multiple network,
and
right?
Possibly multiple networks. So you need really to tell the router on which interface you want to downsample. So you list here the interface on which you want downsample. So here a Wi-Fi interface. You also describe the flow direction.
Right.
Here we want to downsample the egress communication. Possibly sometimes the ingress, but here it's really the egress. And we have the rule which are similar to what we had in the bridge with a key expression and a frequency.
Yeah. And so I think there is an important point because we have feature parity, but what we have now actually paradoxically is a generalization.
Yes.
Because with the bridge, we were, and that was most of the use cases that we were seeing, downsampling were going out, right? Notus case was the India Autonomous Challenge, right?
Yes.
But here now with the Zeno router, you can also downsample inbound. So if you have some robots that actually cannot keep up with some of the traffic, you can already downsample inbound, which is nice.
Yes.
And I think the other important things that as a team we wanted to maintain, it's very important to have an integration point. Yadu was mentioning this before. But how you communicate inside the robot and how you communicate outside the robot, which means the transport, the security concern, and even the granularity at which some data is available, doesn't necessarily need or doesn't need to be or can't be the same, right? And this allows for the right flexibility and configuration.
Absolutely. Yeah.
Any comments from you, Yadu?
No, I think exactly what you described right now. This is very important.
Yeah.
So maybe you notice that the key expression used here in the configuration is slightly different from the regular expression we used in the bridge. And the reason is really that here it's really a Zeno key expression, which is slightly different of regular expression. And I will explain now what's the difference and what is a Zeno key actually. So a Zeno key is a string made of one or more chunks, and the slash is a separator of the chunks. A chunks cannot be empty, and it cannot contain some specific character which have a specific meaning for Zeno. Those characters are the star, the dollar, the question mark, and the hashtag. That's a simple Zeno key. And now we have key expression. So a key expression is a way to select or to match a different set of keys. A key expression match one of more key using wildcard character. And wildcard character, we have, for instance, the double star. which is used to match a set of chunks, 0, 1, or more chunks. We have the simple star, which matches exactly one complete chunk. And we have $star, which matches a substring with it a chunk. So concretely, what does it mean? For instance, A/star/b is a key expression that will match A/c/b. But it will not match A/c/d/b because here we have two chunks and here one star is matching only one chunk. If I do A/star/b, star is matching several chunks, so it matches A/c/b, also A/c/d/b, but also A/b. Because empty chunk is also matching double star.
So it's 0 or more.
Yeah. So now, what if I would like to match a chunk which contains only a C character? Well, I just do A/$star for any character before C, and then $star, any character after C/b. And this will match A/xcy/b, A/cool/b, and A/c/b. Okay?
Pretty clear.
Pretty clear. So if we go back here to this key expression here, we can see here it was any character before a slash laser scan. So this was to say, okay, we need to have any namespace, but with for the topic laser scan. Here we have one star with a slash. This first star will be actually for the domain ID. I will show you just after why we have this one. And then $star % laser scan, and I will explain now why the percent is coming from, but actually this $star is equivalent to the dot star we have here in regular expression. The percent is equivalent to the slash we have here, and laser scan we have it here. Okay, same for /tf. I just need to have a star here for the domain ID, and then just
and again, domain ID. These are ROS concept projected. Yes,
exactly.
As we will see how they are mapped into.
Yes. So actually, let's see now how ROS names are mapping to Zeno keys, because that's quite important to understand the way to configure those downsampling and then the access control also. So for a domain ID and for a specified fully qualified ROS name, a Zeno key expression will be the ROS domain ID / the full name, which is mangled. And here, mangled, we mean all the slash in a ROS name are replaced with % character. So for instance, if we have a domain ID 0, it means a topic cmdvel will use a key expression 0/%cmdvel, because we have the slash global workspace as in front when mapped over Zeno. If we use a namespace turtle1, for instance, so turtle1/cmdvel will be mapped to 0/%turtle1%cmdvel. For services, it's the same, because Zeno uses queryable to map services, and they use directly the same key expression than for topic, for instance. So for services, we use 0/%/add2ints, for instance.
As a queryable.
As a queryable expression, and as the expression to query the service. Exactly. Yeah. Actions is quite more complex, because in an action is composed of 3 different services: the send goal, the cancel goal, the get result, plus 2 topics for publication, which are feedback and get status. So for a pause action, we keep a similar mapping to what we used to have with DDS, but here with the Zeno key expression, it will give 0/%pause, %_action to notify all of these key expression are for action, and then %send goal, %cancel goal, %get result, %feedback for the publications, and %get status for the publication.
So you said, I think maybe you missed. So you said we keep the same mapping as DDS. No.
Well, it's with DDS. I mean that with DDS, the actions were mapped on services, and the way to map on topic name in services was also to use a suffix named _action.
Okay, fine. But
So
the mapping
in
is
the way,
under the hood is completely different because we are
mapping is
mapping to credible.
yes, the mapping is completely different.
I just want to avoid that.
Yes. So
ambiguity.
my point was just that
The
in the
name
same way as
mapping,
in DDS, we have this underscore action suffix, which is used to distinguish between services and actions. So now let's try
access control.
Access control, a little bit more complex one, right? Because in the bridge, it was relatively straightforward. We have allow rule for publishers, for subscribers, for service servers, service client, action servers, action clients. And we just specify regular expression corresponding to the topics or the service names that we want to allow. Now, access control in Zeno, again, it's more advanced, more developed, because it's really a router and we need to have access control on several interfaces. So we enable it. We set a default permission, for instance, which is deny. So everything will be denied, but the rules that we will allow here. So for this set of rules, for instance, we will allow the action put. So this is equivalent to a publication. Put in Zeno is a publication. The flow is egress. The interface still Wi-Fi,
for instance. Yeah.
And here we have the set of key expression. So we have here the laser scan, which is equivalent to this one. We have the TF topic. We have the pause topic. And we have, for instance, here the actions, the publication for the rotate absolute actions. So it means this will allow all the feedback on get status publication for this rotate absolute action. For subscription, in Zeno, it's named declare subscriber. So in Zeno, all the messages which are going out when declaring a subscriber are named declare subscriber. So here we allow the declare subscriber over Wi-Fi for CMD vel, for instance. And for queryable, we allow declare queryable. So it means allow service server on Wi-Fi for all the parameters services, for instance. And same for client. For client, it's a get operation. So we allow all the get operation to go egress and for the same key expression. For actions, well, it's just the way we just need to allow the declaration of queryable for action server on the rotate absolute actions and then $* to say cancel goal, send goal, and get result, and so on.
Yeah. And again, this is quite important because it allows us to do some form of access control that can be security related, but also can control the level of data that you spread in the system.
Absolutely,
right?
Yes.
Which is also important,
Yes, because you certainly don't want to have all the internal topics to your robot to flood your wireless network.
Yeah, and again, although Zeno Discovery is relatively lightweight, still having the ability to only expose what you need, we always should start with the parsimony principle.
Yes, that's more careful.
Yeah.
So another very useful configuration that we had in the bridge was the namespacing. In the bridge, we had the possibility to specify a namespace, and the bridge was automatically adding this namespace on the fly for the external communication over Zeno. So the ROS nodes configured in the router doesn't need to have any namespace. There is no yet equivalent in Zeno because it's not yet implemented, but we foresee maybe to have the possibility to do some remapping of key expression made by the router with a prefix or whatever. But it's still not here. So for now, the solution is really to declare the namespace for each node in the launch file. That's the usual ROS2 way to do it, as it was for a very long time.
Yeah.
So finally, what are the main differences between using RMW with DDS or plus the bridge or using RMW Zeno? First, important difference is with regard to the ROS graph. With the bridge, all our ROS system is seen as a single node from the outside. It means the bridge is already hiding all the set of nodes that is running, and from the outside, you can see only one bridge which represent all the connectivity you have in your robot. With RMW Zeno, now you have the full possibility to see the full connectivity of all your nodes. As we saw in the demonstration, you can just start RQT and you get a full visibility of all your nodes in your ROS system. Transient local is also another difference, because using the bridge, we needed to have the bridge which are caching the publication for the lab subscriber, because we cannot get back to the original DDS subscriber from outside Zeno to get the historical data, right? So the bridge are acting as a cache for those transient local publisher. And the issue with this is that if you have several publisher transient local on the same topic, they are all going to the same cache in the bridge, leading to possible overwrites between each other. With RMW Zeno, there is no longer this problem. Each node is caching its own publication, similarly to a DDS system. Namespacing, as we saw with the configuration, is also another difference. With the bridges, you can configure namespacing on the fly. With RMW Zeno, you use the regular way to configure nodes, ROS nodes, in the launch file. You just specify your namespace. Finally, when to use what? When shall I use RMW Zeno? When shall I use DDS with a bridge? So currently, Zeno can be used with iron release, with JZ release, or with rolling. So you can use RMW Zeno here, but also DDS with a bridge. For earlier version, Humble, Foxy, and so on, you need to use Zeno bridge ROS2 DDS because RMW Zeno is not available yet. Yeah. There was slight some changes in the RCL layer, if I remember correctly, Yadu, that make the current code of RMW Zeno not compatible with Humble.
Yep, that's right.
And so, when do you want to use RMW Zeno? Well, if you have some issues with the bridge, because they are good, but they are not perfect. There are already some issues which I described, but there are also some pending issues we need to fix. If you need also the full ROS graph view, and of course, if you want to experiment the latest features and you want to contribute to the success of RMW Zeno, we encourage you to try it and to give us some feedback and to fill some issues if you encounter, so we can improve and make it work very well for everybody.
Okay, thank you very much, guys. So we have 1 zillion questions. So I would say let's start from top to the bottom and let's see where we arrive. We'll try to answer as many as we can. So, but before getting to question, I would like to thank you, Yadu, and Julian. Very informative, very interesting. And beyond that, thank you, for I think it was a super was developed in record time, and I think it's very, very good to see it already working to the level that we see. As it was mentioned before, I think we both look very much forward, the community, to can you turn off the screen? Yeah, to actually give it a try and give us feedback. I think we just want one thing, which is to make it at better RMW, right? And improve it one day after the other. So thank you very much. Looking forward doing more and greater things together. And let's get down to the questions. Okay, so first question from Pattern asking, well, actually, I don't think his name is an anonymous observer, whatever. But in any case, we'll answer a question anyway. How is it different from DDS router? Well, first of all, that's a philosophical question. Zeno, it's a routing protocol in reality. Okay, in Zeno, a router is no different than any application. Zeno can do mesh, and I would ask you to refer to any of the Zeno tutorial that explain how Zeno works and how different is DDS. In DDS, there isn't really a concept of a router. And once again, maybe can you post a link, Julian, on some of the work that we did over 10 years ago? I think that will shed some light. Then another question, for safety purpose and standard, isn't DDS better, always from an anonymous observer. Well, for your information, Zeno is also adopted in automotive and is undergoing certification. So I think that solves that purpose. And Zeno is completely open source, part of the Eclipse Foundation. So that's quick. Okay, then let's see next. This one we've ever answered. This one we've already answered before. Okay, question I think for Julian from Rodrigo Gonzalez. Why did Julian run a Zeno router in AVM and then another Zeno router on his PC? Why not just in his PC?
So just to have easy NAT traversal, right? Because Yadu is running all his ROS system in a closed environment. It was in a cloud in Singapore, right?
Well, in his company, right?
His company,
we cannot get it. Yeah.
Yes, and so I cannot configure my own router in my PC to directly.
We are on our own company with firewalls. So just for everyone to realize, right? We made this demo work with laptop that I'm running on secure company networks.
Yes,
that's why we were running a router outside.
And running on Wi-Fi, by the way.
Yeah, running on Wi-Fi. Yeah.
And yes, so the easy way to really cross the NAT is just you deploy a router on a public IP, and you have all your ROS connectivity, your ROS system with Zeno router connecting, establish outgoing connection to this public IP. And the router in the cloud will do all the forwarding of traffic between the two systems.
Okay, there is another question asking, what is the difference between gossip and multicast scouting? Maybe I'll get this one real quick if you want, and I'll let you get the next one as I answer this, okay? So scouting in Zeno is just a way of bootstrapping, bootstrapping by finding endpoints. The scouting protocol actually is not part of the core Zeno protocol. It's like a sub-protocol that Zeno uses to bootstrap the Zeno protocol itself. As such, we support multiple scouting protocols, one of which leverage on plain multicast, okay? The other one, which is the gossip, which essentially allow us to find an anchor point, either by multicast or because you provide us by configuration. And from that anchor point, we do a closure, literally, okay, of the Zeno network and discover everything else. That's the difference. But again, scouting is just about how do I discover who is around? And then once I discover who is around, we have another protocol that is used to sort out the topology of the network and then to do mesh routing. You take the next?
Yes.
And then we should search for some ROS specific. Yadu, as soon as we have some more ROS or RMW, we'll get to you. And I'll keep skimming.
So question, do you have to specify where the other routers are in the JSON config? Will it be automatic if in the same LAN? So actually, yes, you always have to specify where are the other routers.
Well, at least one of those.
So there are two different configurations, right? You have the configuration of the nodes, for which you don't need to specify anything because by default, they are configured to connect to the local router on local host loopback interface. But for the configuration of the router of your robot, if you want to connect to make it to connect to other Zeno router for another ROS system.
Correct, but you need at least one, then you could.
So you need at least one, but then if you want to enable auto connection between each other, you need still to enable the auto connect configuration for the router. Otherwise, they won't auto connect to any other router.
Yeah.
And that's precisely to avoid issues which some users have, like for instance, student labs. In a student lab, you have several robots, right? Each of the students have their own robots. But all of a sudden, with DDS, if you connect all to the same network, they all are interoperating with each other, and it's really a mess because they are all using the same domains or the same topics names. So by default, with RMW Zeno, a robot will not connect to anything. So each student can configure its laptop to connect explicitly to one robot,
of course,
or to several robots in case of fleet management. So you really control what you want to connect to which robot.
Correct.
But still, if you want to have automatic interconnection between all a set of robots. You just change the configuration of the router to enable auto-connect between routers for the gossip squatting.
Yadu, one question for you. How does Zeno support ROS2 Humble, or if there are any plan for it?
Yeah, right now, the way we do our development, we're always developing on rolling. So it just so happened that the rolling API was compatible with the Iron API. When I say API, I'm referring to the RMW package. So in the future, we could potentially have a Humble branch in RMW Zeno and then selectively update the code there. But it would make things like backporting a bit tricky. But it can be done. I don't see why not. But it's just that we're a small team, and so far the focus has been to develop on rolling, which would eventually become Jazzy. So we primarily target Jazzy, but just so happens that the API is compatible with Iron. So it also works with Iron.
Yeah. Other question for you, Yadu. I heard that to test RMW Zeno with Jazzy, I need to build Jazzy from source. Why is that?
No, that's no longer required. I think we just updated the description post on Discourse over the weekend. So I think there was a mistake in the post where it said that you have to build Jazzy also from source. That's not needed. You only have to build RMW Zeno from source. You can use Iron binaries, Jazzy binaries, rolling binaries. It's totally fine.
Okay, thank you, Yadu.
So what's the next question? Do we have to specify different domain per router robot, or everything in the same domain will be fine? So actually, if you control all the connectivity between all the routers, you can use the same domain for all, right? Because if you have two sets of ROS systems which are interconnected in a distinct way, they won't communicate with each other anyway. So you can really use the same domain for all. It's only in the case you want to interconnect all your routers, but still have some robots which are distinct system for other system. You don't want them to communicate. Then you will need to either use namespacing, either use domain ID.
Yeah. Okay, good. Then there is a question from Martin asking, when using RMW Zeno, are best F4 QoS topics transmitted over UDP or still over TCP? Well, that depends on the transport that you've set up, okay?
By default, it will be still use TCP.
Because that's the only transport that is set up. Otherwise, you have to enable also UDP. But again, on a single host, honestly, the IP stack leverages shared memory optimization. So, I mean, you won't see much different. And TCP IP behaves better than UDP. So I would not necessarily change that for intra-host communication.
Yeah.
And across the host, I wouldn't use UDP either. What I would do, I would use Quick.
Yes,
That's
Quick.
What we do.
Quick is more will be more reliable than UDP. Yeah.
Under which condition does the discovery information gathered by router deprecate, i.e., when the other router providing stops being reachable? So that's dealt by Zeno, right? So in Zeno, we keep a reconstruction of the topology and the interest. And again, I say the interest because, again, Zeno tries to be scalable. So we do lots of consolidation of information. And whenever a router or a peer or any Zeno endpoint is assumed to be gone, obviously that information will be reflected on the network. But there are timeout, and you can configure the liveliness by means of that Zeno configuration file. Okay, so maybe you can take this, Julien. Just to clarify, so the main difference between Zeno RMW and the plugin or bridge is TCP versus UDP? Well, not really. So,
well, it's more than this, right? It's really that inside the robot, DDS protocol is running, and DDS by default is running over UDP. But it's really a different protocol with different behavior. And as Angelo mentioned, there is, for instance, a drawback, which is all the discovery protocol with DDS, which can be some cumbersome and which will most of the time flood a wireless network, for instance.
There are other challenges, right? I mean, containers. All of a sudden, you're running things on container, you're using NetHost. It's very, very hard to contain DDS discovery. I mean, it's a mess, right?
yes, it could be quite challenging if you have a lot of different nodes running in your robots in different containers. They will all discover each other by default, but sometimes it can be too much for even for an internal network. So it's really a different behavior. So you have Zeno running over TCP on one side and DDS running over UDP on the other side. So,
and again, I mean, you could have Zeno running on UDP if you want. So that's really not the point. I think what is the most important things between RMW versus bridge is that with the RMW, as it was mentioned by Yadu and Julian, you're using a single protocol, first of all, right? We are in, let's say, addressing some of the limitations that we had in the bridge with respect to the graph. And at the same time, we are not losing, and that was a design goal, right? We are not losing the advantages in terms of integration that the bridge used to give. So it's kind of the best of both worlds from my perspective. I don't know, Yadu or Julian, if you want to add anything. I think that's a very important point, right?
Yeah, for me, it would be you're running one less process. You don't have to run another Zeno router with this plugin. Your ROS nodes natively communicate with each other, and you have the existing RMW Zeno router that will just connect to another router somewhere else. So that could be some memory footprint CPU savings. But essentially, you're also you benefit from the rest of the ROS tooling. So RQT graph, you'll be able to see all the nodes and topics just as you would with other middlewares. Whereas as Julian highlighted with the bridge right now, you'll just be seeing one node essentially.
Okay. Okay.
yeah, so
we are still not close to being done. Yadu, do you have any strong time constraints?
Probably 10 more minutes from my side.
We have loads of people still online, massive number of people. So I think, yeah, let's see how long we can go. When you have to drop, we'll drop, and we'll take the rest, okay?
Sure. Thanks.
So what if you want to connect robots that don't run on ROS? So actually for this, you can leverage the similar plugins that we made for ROS2, but also for MQTT, for instance. We have a plugin for MQTT, and we already in the past made demonstration where we can interoperate MQTT system with a ROS system. You just need to have possibly some script doing data transformation, right? Because in ROS you have encoding in CDR, in MQTT.
We have a full webinar on this.
Yes, we have a full webinar on this.
Daniel, I don't know if you are there. Can you post a link to the walled garden problem? Yeah. Then moving to the next question, which is, will the subscriber know that they're receiving unsampled data?
No, they won't.
I think that's good.
Exactly.
Okay. Because if you start propagating all this information, you will get back into discovery issue. Other question from Martin that asks, can downsampling be specified per subnet instead of per interface? Our robots have multiple computers connected. So let me answer this indirectly. Actually, in the router, the way in which we do downsampling is with interceptors. Our routers support interceptors. So you can do whatever you want in interceptors. Sky is the limit. For our specific settings, I am not sure. We'll check and get back.
I don't think so.
I think it's by interface.
It's per interface for time varying, but it's maybe a good idea to make this,
so good
to add this feature.
Yeah. But otherwise, I just wanted to make the point that we have now an interceptor mechanism, and you can use it to do pretty much whatever you want. And the performance impact is marginal, which is quite important. Yes. That was a design goal. Okay, so this is a long message.
So what will is the second? Is the question?
Hold on.
Not sure to understand the question.
Well, yeah, because, I mean, again, Zeno works very, very differently from DDS, okay? And some people are surprised to see that even when two robots connect, maybe there is just one discovery message being exchanged. So what I suggest to Alsora is either reach out with an expanded question or look some of the webinar on Zeno that explain how our discovery works, and then yeah, or otherwise, reach us out on Discord. Maybe we can post the Discord link. Is it possible with DDS? Okay, let's see.
How do we handle large messages?
Like point clouds.
I think quite well.
Yeah, I think quite well. And again, as I mentioned before, so off the shelf, I think quite well.
Yeah, because we actually, so Zeno by default support very large payloads, right? Several megabytes. We already did some tests. So Zeno does its own fragmentation.
Let me share this. Yeah, go ahead. I'll show
so
you.
Zeno does the fragmentation of the message when to cope with possible small MTUs and do the full reconstruction at the reception side.
So, and here I've posted a link to a performance benchmark that shows the kind of throughput you can expect.
Yeah.
And now I've lost the message. Oh, here we go. Was it this one?
Yes.
Yeah. And then again, as we discussed before, would be very much interesting to, as a next feature in the RMW, to really add support for true zero copy, right? So can we use DDS security with the Zeno bridge?
No.
Short answer, well, if you configure Cyclone 4, you could. Yes.
No, currently the bridge are not built with DDS security enabled. I think we had issue with the building
With
of
static
Cyclone DDS. Wait, with
Okay.
exactly with static library using OpenSSL
Okay.
in the bridge configuration. So
But
currently,
so it's yeah. So, but there is nothing that limits it.
no, we just need to work on this.
Yeah.
That's a ticket which is I think still open. We need to address it.
But personally, I wouldn't advise to use that within a robot. I would secure my network, and then with IPsec, that's far more lightweight. That's what I would do, and then secure the communication outside of the robot. Okay. By the way, some people are congratulating Yadu with the availability of the RMW. So absolutely. And again, how can the community help? So that's a question again on the floor, Yadu.
Yeah, firstly, I want to highlight that this has been an incredible team effort. So there's other engineers, Chris Lalancet, for example, Morgan Quigley also involved in developing this RMW. So it's congratulations to everyone. And in terms of testing, I think a lot can be done. So RMW Zeno is in what I call a beta stage. I think it works out of the box, but it still has a lot of things that can be improved. We'd love to hear how people are using it. Whatever you're running right now, try running it with RMW Zeno. If you run into any bugs, feel free to open issue tickets, and we'll take it from there. You may have your own testing frameworks or testing stacks that you might use for your existing applications. So give it a spin with RMW Zeno and let us know your results in terms of performance, also in terms of usability and the out-of-the-box experience.
And actually, we went through all the questions, so we made it.
Okay.
So, guys, thank you again.
Thank you, Yadu.
By the way, the funny thing is that the attendees, instead of going down, they are going up. So if we remain another half an hour, I don't know where we'll get. But yeah, I think it's time to move forward. So again, thank you for this great webinar, guys. And looking forward, perhaps, to more in the future. And thank you
to attend. And if you have more questions, feel free to join our Discord and to post questions.
Our Discord or ROS Discord, right? We are both community are on Discord. So yeah, see you on Discord then. Thank you, guys. Bye bye.
Thank you.
Bye.
Bye.
Ciao.
Goodbye, everyone.